Alright, now let's talk about two conditions that happen. Yeah, normally asked in the questions. Battery connected and disconnected. Battery connected and disconnected from the capacitor. And we do some changes on the capacitor itself, maybe the internal structure of capacitor, and see what happened. Okay, see what happened to other quantity like the charge, voltage, electric field. Okay, like this one. Yeah, we see what happened to the charge in the capacitor, capacitance, the voltage, the electric field, the potential energy stored in the capacitor. Okay, if we do some changes like removing dielectric, increase or decrease the distance, or insert the dielectric, yeah, under these two conditions, the battery connected, disconnected, or remains connected. And now let us learn about this the first situation. Okay, we just insert the dielectric and see what happened to these two conditions. Okay, let us start off with the first condition, battery disconnected. Yeah. First of all, we have a capacitor. We have a capacitor which is being fully charged by the battery. This capacitor is already fully charged by a battery. It's connected to the battery and being fully charged. So it has a full charge here. Yeah, full charge here. But actually, we cannot say this capacitor has a full charge. If you apply to a higher voltage, a higher, bigger battery, more charge will flow into the capacitor. More charge can still flow into the capacitor. So this maximum charge is basically based on the voltage applied. Based on the voltage applied. So this charge is maximum for this voltage. Understand? This charge is maximum for this voltage. If you apply a bigger voltage, actually you will achieve a bigger maximum of maximum charge. Bigger maximum. That means more charge can still flow into the capacitor if you apply a bigger voltage. Now, okay, just assume that this capacitor initially is being fully charged by the battery, fully charged. So since this capacitor and the battery, they are both parallel to each other. All right, they are both parallel to each other. So we can say the voltage across a capacitor has achieved the same voltage across the battery. That means the voltage of capacitor is equal to EMF itself. Same voltage because they are parallel. It's being charged up to maximum. So the voltage of capacitor has become equal to the voltage across the battery. Okay, which is the EMF. And also it stores the maximum charge for this EMF. It stores the maximum charge in the capacitor already. Now, it already has the maximum charge. Now, you disconnect. Now you disconnect the battery. You take out the battery. You remove the battery. Just left the capacitor alone. What happened if you left the capacitor alone? And at the same time, once you remove the battery, disconnect the battery, and then you insert the dielectric inside. This dielectric is inserted after the battery is removed. Yeah, remember, after the battery is removed, just left with the capacitor alone, you insert a dielectric. What will happen to all other values like the charge, the capacitance, the voltage, electric field, and potential energy stored? Let's study one by one. So, once you disconnect the battery and you insert the dielectric, okay, this is the main thing. You see the bracket, yeah, the one I put in the box is the most important clue for each of these conditions. Disconnect the battery and remains connected the battery. For disconnect the battery, remember the charge is constant. For battery remains connected, remember the voltage is constant. These two boxes are the most important clues for these two conditions. We always start off with these two boxes, these two clues. Always start off with these two, and then once we know these two, we can generate all the others changes. Once we know these two things, we can generate all the other changes to other quantity. Yeah, like capacitance, voltage, electric field, potential energy. Understand? Now, let's us discuss first about this one. Okay, battery disconnected. Now, let us look at this one. So, it's only the capacitor alone. Capacitor alone without the dielectric, battery disconnected. Okay, and you insert a dielectric. First of all, for this condition, the charge is always constant inside the capacitor. The charge in the capacitor is constant. And why? Because the charge cannot flow anymore. The circuit is incomplete already. Circuit is incomplete. The charge can always remain inside the capacitor. The charge cannot flow anywhere. There's nowhere to go. It's like being trapped inside. The charge is being trapped inside the capacitor. That's why the charge in the capacitor is always constant. Cannot flow. Yeah, charge is constant. Charge is always constant if you disconnect the battery. That means the charge, no extra charge, can flow from battery to the capacitor, or the charge cannot flow back to the battery also. Yeah, because already disconnect from battery. So no more extra charge can come from battery to store in the capacitor anymore. So charge in the capacitor is always constant once you disconnect from battery. So what happened about capacitance? What happened about the capacitance? As you learned before, if you insert a dielectric, you still remember what you learned in the dielectric constant? If you insert a dielectric, if the capacitor has a dielectric, if you compare with dielectric and without dielectric capacitor, this with dielectric has extra ER. You see, C and C0 has extra ER, or the dielectric constant. That means we can say generally the capacitor with dielectric has higher capacitance because it has the dielectric constant. But for the dielectric without the capacitor without dielectric, C0 has no ER, so C0 is smaller. So that means if you put the dielectric into the capacitor, the capacitance will increase because of ER. Or we call it this is the ER is the relative permittivity or dielectric constant. Okay. So let's look back to this value. So we know that once you put in the dielectric, the capacitor, because initially it has no dielectric, so it is only C0. It's only C0. Now you put a dielectric, it becomes C already. Last time it's only C0. Now it becomes C already. For C, it has extra ER. For C, it has extra ER. So from C0 change to C, it become the capacitance increase. Yeah, capacitance bigger than C0. Okay, capacitance increase. Now look to the formula. This actually formula come from Q equal to CV formula. Q equal to CV. So the C just go below. C go below the Q. When C go below the Q, it becomes this formula, V equal to Q over C. We know that the charge is constant. So the charge is constant on the top. So we know that the C increase because of the dielectric, because of the ER. The C increase. When C increase, V decrease. The voltage of capacitor, the voltage of the voltage of capacitor now will decrease. Last time when charge maximum, it equal to EMF, isn't it? Now the voltage of capacitor decrease. That means now the voltage of capacitor is less than the EMF. It's less than EMF already because the voltage of capacitor has decreased. Okay, less than the EMF already. Maybe last time the EMF is 10 volt. Yeah, the capacitor also achieved 10 volt. But now the capacitor, but now the capacitor itself is only 9 volt or maybe 8 volt. 8 volt only. Yeah, has dropped. The capacitor voltage has dropped. Yeah, from 10 to 8, less than the EMF. Understand? Okay. Now, how about the electric field? Electric field is for parallel plate. You still remember this is the formula for parallel plate. Parallel plate. This is capacitor is actually parallel plate. So if the voltage decrease, we know that the D is the separation between the two plates. So yeah, D is the separation between the two plates. D we never change. Yeah, constant. So D is constant. So only the voltage decrease. Voltage, once you put the dielectric, the voltage will decrease. If voltage decrease, the E also decrease because E is directly proportional to voltage. So the voltage of capacitor decrease, the electric field strength in the capacitor will decrease. And also you already learned in the following, the earlier videos about the effect of dielectric. You still remember the effect of dielectric? If you put a dielectric in between the capacitor, this dielectric will induce this opposite electric field. Yeah, we induce an opposite direction electric field. So the total electric field will decrease. So the V also decrease. You see, this is another way to explain the changes to electric field strength. Okay, once inserted the dielectric, if you put a dielectric there, the electric field will induce an opposite direction electric field. So this opposite direction electric field will cancel the original electric field. So the net electric field will decrease. So yeah, this is the one. So you can use either formula to explain the changes to electric field strength. So if you insert a dielectric, the electric field strength inside the capacitor will decrease because you have an induced EMF. No, you have induced electric field. Yeah, minus, so electric field decrease. Yeah, or you can use this formula also. When V decrease, E also decrease. What happened to the potential energy, electric potential energy stored in the capacitor? So you use half QV. We know that this potential energy has three formula. Either you can use half CV square or half Q square over C. So, but you must be wise enough to choose the correct formula. Don't use the half CV square. Yeah, don't use a half CV square because we know that C increase and V decrease. Yeah, and so very hard to determine the changes for potential energy. But anyway, we also can see because this one has square. So has square, that means the voltage square decrease even more than the C. So potential energy decrease. Yeah, but we don't use this one normally because it don't have a constant value. Better use these two. Better use these two, this one and this one. Why I say like that? Because they have a constant. They have a constant Q there. They have a constant Q there. Do you see that? They have a constant Q. This one is constant Q also. Yeah, these two constant Q. So what happened to the voltage just now? Voltage decrease. Voltage decrease. So voltage decrease, potential energy decrease. How about this one? Can we use this formula? Half Q square over C? Yes, also because we know that C increase when we put the dielectric. When we put the dielectric, the C increase. So when the C increase, the charge is constant, so the U decrease. U decrease. Okay, so we can use we better use these two formula, this formula and this formula. Try to avoid this formula, yeah, because got two changes, very hard to determine. But if depend on the square, we roughly can know what happened. Understand? Better use this half QV and half Q square over C because they have a constant value Q. Okay, and only left with two variables to see the changes effectively. Now, let's talk about what happens if a battery remains connected. If battery remains connected, that means if you don't remove the battery is still connected to the capacitor. While the battery is still connected to the capacitor, you insert a dielectric. What happened? Yeah, you insert a dielectric while the battery is still connected. What will happen? Of course, the immediate changes is this. The immediate changes is the moment you insert a dielectric, the moment, listen carefully, the moment you insert the dielectric, while the charge is still constant, not flowing anywhere, the electric field will decrease. Electric field in the capacitor will decrease. And the voltage of the capacitor will immediately decrease. But that's not for long. That's only the immediate changes. Okay? But after some time, the voltage will go back up. The electric field strength will also go back up. Yeah? Let me explain here. The moment, listen carefully. Now I want to write some more over here. The immediate, yeah? Listen carefully. The immediate changes is this. The moment you insert the dielectric, while the charge is still constant, not flowing, the immediate changes while you put the dielectric inside is the electric field will suddenly decrease. Because why? Because the original electric field is being cancelled by the induced electric field. Is being cancelled by the induced electric field. The immediate changes is electric field will decrease, and then the voltage of capacitor, which is because E equal to V over D, isn't it? So we know that when the electric field decrease, the voltage of capacitor also will decrease. That's the immediate changes. The voltage of capacitor will decrease also. That's the immediate changes. But that's not for long. After some time, it will go back up. That means this charge is not constant forever. This charge will increase some more. More charge will come from battery to go into the capacitor, and this voltage of capacitor will go back up. The electric field strength in the capacitor will also go back up. Let me explain again. Like this. When you charge a capacitor, when you connect the capacitor to the battery, it charge to maximum become 10 volt. The moment, while the battery still remains connected, the moment you insert a dielectric, this one, the battery which is 10 volt, okay, the capacitor will suddenly drop. Yeah, will suddenly drop less than the EMF. It become only maybe 8 volt. Understand? While the charge is not still constant, the capacitor will suddenly drop the voltage because of the dielectric, because of the cancelling of the electric field strength. Electric field decrease, voltage also decrease. The voltage of capacitor will suddenly decrease to 8. But after some time, the battery will further charge up. More charge will flow from battery to the capacitor, so the voltage of capacitor will go back up in order to be equal back to the EMF. Because anyhow, this capacitor is always parallel to battery. It's always parallel to battery. The voltage of capacitor cannot remain at 8. Cannot remain at 8 because capacitor is still connected to battery. Is still connected to battery. That means the capacitor is still parallel to battery. So it cannot remain at 8. This voltage has to go back up in order finally to be equal to the EMF. That means this 8 volt will go back up to 9 volt, will go back up to 10 volt ultimately. In the end, what I can say is, in the end, the capacitor will be equal back to the EMF. Understand? Because they are always, the battery remains connected. The battery is still there. So in the end, the voltage of capacitor have to be equal back to the EMF, which is 10 volt. Okay? So the moment you put in the dielectric, the immediate changes is the voltage of capacitor drop. It will drop immediately from 10 to 8, but the charging process will continue. The charging process will continue. That means from 8 volt, it will go back to 9 volt, will go back to 10 volt. So that finally the capacitor voltage, the voltage of capacitor will be still equal back to the EMF. Finally, it go back to EMF. Yeah, because they are parallel, the voltage of capacitor has to be equal back to the EMF finally. Understand? So, in short, if we don't want to see the immediate changes, we just want to say what happens in the long run. What happens in the long run? It is this, the below here. In the long run, that means finally, when the capacitor go back up to the same voltage as the EMF, the voltage capacitor equal back to the EMF. In the long run, this is the thing happen. For the battery remains connected condition, in the long run, not the immediate changes. In the long run, the voltage of capacitor considered to be constant. I know there's happening. There's changes in the middle. The voltage drop and then go back up, isn't it? But I just want to say what happens in the long run. In the long run, or say finally, the voltage of capacitor go back up to EMF. Or voltage considered to be constant. Constant. Yeah, that means constant here. It means the voltage of capacitor go back up to the EMF because it's parallel. Because battery remains connected parallel to the capacitor, the battery, yeah, parallel to the capacitor remains connected. So the voltage considered to be constant. So there is a difference between disconnect battery and connect battery. Disconnect battery, the charge cannot flow anywhere. The charge in the capacitor is always constant. Yeah, charge is constant, but the one battery remains connected. In the long run, consider the voltage is constant. This one charge constant, this one voltage constant. Okay, this is what happened in the long run. Yeah, voltage considered to be constant, and we know that we put a dielectric. The capacitance will increase because of the relative permittivity. You understand? Because of the relative permittivity, the capacitance increase. That means the capacitor now has higher ability to store charge, able to store more charge. And Q equal to CV shows that the voltage is constant. Okay, the voltage here is constant. So we know that the capacitance has increased. So the charge in capacitor will increase. What does it mean by this? The charge in the capacitor increase. That means more charge has added to the capacitor. That means more charge flow from battery to the capacitor. Why more charge have to flow to the capacitor? Because just now I said the voltage of capacitor has dropped to 8 volt. Yeah, from 10 volt dropped to 8 volt. So now the voltage has to go back up to 10 volt. So that means if you want to go back up, you want to increase back the voltage, more charge has to flow from battery to capacitor. More charge has to flow from battery to capacitor. This is the additional charge. Additional charge flow from battery to store in the capacitor so that the voltage will go back up to 10 volt equal to the EMF. Okay, because now the capacitor has higher capacitance already. Higher capacitance for the same voltage, you know, battery remains connected for the same voltage. Higher capacitance can store more charge. The capacitance formula C equal to Q over V. Because we consider the voltage to be constant, isn't it? We consider the voltage to be constant. That means that we still battery remains connected. Battery remains connected is still a 10 volt battery. 10 volt battery and 10 volt battery. Last time without the dielectric, maybe it can only store without the dielectric, maybe it can only store 80 maybe last time without the dielectric, the 10 volt battery connect to the 10 volt battery, the capacitor can only store maybe 50 coulomb of charge, 50 coulomb of charge. But now with dielectric, still connect to the same 10 volt battery, same voltage. Of course, still connect to the same voltage, and you have dielectric already. The capacitance increase, isn't it? The capacitance increase. That means it can store more charge. Now it can store more charge. That means more charge will flow from battery to the capacitor. That means now the charge can become maybe 80 coulomb. Last time for the same voltage, without the capacitor, without the dielectric, it has a lower ability to store charge. Lower ability to store charge means it can only store 50 coulomb. But now with dielectric, it has higher capacitance, higher ability to store charge. So for the same voltage 10 volt, it can store more charge. That means it can store 80 coulomb instead of just 50 coulomb. You understand? So that's why I say when the capacitor increase, charge increase. For the same voltage is constant. So that means more charge now will be added to the capacitor. From where? Where the charge come from? Actually, all the charge come from the battery. That means the battery will further charge up. The battery will further charge up the capacitor. As I said before, this charge, although we say is being charged to maximum, but this charge is not always maximum. This charge that can be stored in the capacitor depends on the ability of the ability to store charge. It depends on the value of capacitance, depends on the value of the voltage. So the charge can change. You understand? It's not always, it doesn't have a maximum value. Charge doesn't have a maximum value. It depends on the capacitance. It depends on the voltage applied. All right. So understand? So now for the same battery, voltage is constant. The capacitance has increased. Because the capacitance increased, it can store more charge. More charge will added to the capacitor from battery. Now, how about the electric field? Electric field, because the voltage is already constant, so D also no changes. So V constant. If V, we know that the V is constant, so E also constant. V constant, E also constant. I know the immediate changes is V decrease, but we know that after some time, the V will climb back up. The immediate changes just now, electric field also decrease, but electric field also will climb back up. To be equal to the original electric field. Understand? Since the voltage drop, but the voltage will go back up in order to be equal back to the EMF. The EMF, the electric field just now, it dropped suddenly. It will also climb back up to be equal to the original electric field. Okay, so in the long run, we just say that electric field is constant. Yeah. Constant here, it means equal back to the original electric field. Okay. Now, how about this potential energy? Electric potential energy use half CV square. Why I use half CV square? Why don't I use the other formula like half QV and half Q square over C? Let's investigate which formula is better to use. Which formula is better to use? Okay, half CV square, of course, because it has the constant value V there. This V is constant. V here is a constant, so easily can left with only two variables to see the changes. So the capacitor increase, isn't it? Once you put the dielectric, the capacitor increase, energy stored in capacitor increase. That means, of course, more charge is added to the battery, isn't it? When more charge added to the capacitor, when the capacitor store more charge, means it store more electric potential energy. Okay? When the voltage considered to be constant. When more charge added to the capacitor, when the capacitor store more charge, it store more electric potential energy. So the potential energy is expected to increase also. Or you just use this formula, half CV square. Voltage is constant, C increase, U increase. Potential energy increase. Last time is potential energy decrease. This one potential energy increase. So now, how about this formula? Can we use this formula also? Yes, also, because we have a V constant here, constant. So we only have two variables, U and Q. So what happened to the charge? What happened to the charge? More charge added to the capacitor. That means the charge increase. So the charge increase. Charge increase means potential energy increase. Because now capacitor store more charge. It store more electric potential energy. Okay, store more electric potential energy. How about this one? Can we use this one? Q increase. We know that Q increase. C increase also. But so you have three variables here. Not so good. Yeah, not so good. But anyway, we can see here we have a square. We have a square here. That means the charge square increase even faster than the C. The charge square increase even faster than the C. So overall still increase. Yeah. Sorry. Overall considered to be still increase because you have the Q has square. So Q square increase faster than the C without square. So overall is increase. So potential energy increase. Okay, so that's all for battery disconnected and remains connected. Disconnected, Q constant, remains connected, V is constant. Remember these two key. If you know these two key, you can know all the others. Just play with the formula. Okay? And then now is our last video. Thank you. Bye.